Three main steps to doing an arc flash hazard assessment. First step is data collection. Boots on the ground in your facility, tracing wires and panels and circuit breaker settings, all kinds of stuff. We'll talk more about it in a minute. Engineering is the next phase. That's where computer models are built of your system. Calculations are made, recommendations are written, and that's all done for our company in Plainfield, Indiana. Delivery is the next step. That's when the people come back, give you labels, put labels on, show you the report, talk about the good news, talk about the bad news in the report, and work out the details. Let's look at data collection. All kinds of stuff is going to be collected. Information about your transformers that only engineers could care about. Information about your wires, wire sizes, fuses, circuit breaker data, all kinds of things. We kind of refer to it as an autopsy of your electrical distribution system. An autopsy. You know, you've watched CSI, they look at everything, that's what we're going to do. That's why stay away from those people that just say, send us your drawings. You know, you're not going to have accurate drawings, and if you did, they're not going to have everything on those drawings that you need. You have to have people in your plant breaking a sweat, boots on the ground. We're going to talk to the electric utility company. We'll end up developing accurate one-lines of the stuff we look at, and it's quite amazing. You might be thinking, how long does that take to come look at all my wires? Well, how big is your building? You know, are you a 1 million square foot drive shaft company, or are you a 100,000 square foot water bottle warehouse? It makes a big difference. And there is no standard. It just depends on what you do and how big your facility is. If anybody was curious how long it might take your facility, we regularly, for free, go around and do walkthroughs. We just call them walkthroughs. We'll send an engineer or a project manager, field technician, just come walk through your plant with a clipboard. And pretty quickly we can tell you how long it might take to do your facility. Engineering phase. Lots of things are going to be calculated. A short circuit analysis. This is, for you non-electrical people, if you just bolted two wires together in your building, your great big one, we actually calculate how much current would flow. I'm not recommending you do this. We'll calculate it for you. Don't bolt them together. A protective device coordination analysis will be done. This is to make sure that the proper fuses and the proper breakers are set the proper way, and that the proper breaker trips. Think about your toaster at home. If your 3-year-old throws the fork in your toaster at home, and your main circuit breaker trips for your house, the entire house goes dark, your house is miscoordinated. If it just trips the 20 amp breaker feeding that receptacle, your house is coordinated properly. That's what we do in a factory. It's a lot more detailed than throwing a fork in a toaster, but same principle. Interrupt rating analysis will be calculated. This is make sure that the fuses will actually interrupt the amount of current that we calculate might be there. Okay? And then, of course, we do the arc flash analysis, and then the mitigation recommendations. The mitigation recommendations are those recommendations to lower the hazards that we find. And this is why you're doing it. And oftentimes it's left off. But make sure if you ask companies for quotes on how to do your arc flash or what it's going to cost, request mitigation recommendations. Delivery. We'll deliver labels. A book looks something like that. We'll explain the report, the good news in it and the bad news. We'll affix labels. We'll talk about the mitigations. And we're going to want you to categorize them. What's that mean? Well, in a plant, to give you some idea, first of all, some people are scared about doing an arc flash analysis because like, oh, we're going to find all these problems. Well, in all the work we've done, about 80% of all panels in the hundreds of thousands of panels we've looked at were okay. 80% needed no work. They were already zero. They were already Cat 0. This could be different for your plant. Better for yours, worse for yours. Just depends on what the situation is. So only 20% might come with mitigation recommendations. Of those recommendations, about 80% of those are going to be easy. Things like adjusting a circuit breaker setting, changing a fuse. But there might be some of those recommendations, 20% maybe, that are difficult. Change a complete circuit breaker completely. Maybe it's a big expensive one. Replace a panel board, maybe. Those are more expensive. The reason I say categorize them, don't wait and do them all at once, because some of them are hard. Do the easy ones immediately. If an engineer tells you adjust a circuit breaker and take a panel from a 4 to a 1, why in the heck would you not do that this afternoon? That takes no time to do. And that's what happened at Simmons Bedding. All they had to do was adjust a circuit breaker. Our electrical engineer, Amanda Jarrow, wrote that, and you should have seen her face when she read the email, but nobody got hurt. It was a big deal for her, big deal for all of us. So if you get a bunch of easy recommendations, jump on them immediately. Jump on them right away and get them done. The harder ones, you might have to ask your boss for some money. All right, we'll put those off a little bit. But the ones you don't need to ask money for, get on them and get them done. Just overnight, you'll make your plant safer. And there's not a lot of chances we get to do that, is there? That quick. So make your plans on the mitigations. And prior to this stage, you must have all your clothing policy in place. Because here's what's going to happen. If you don't already have FR clothing, we're going to put labels on your equipment that says someone needs a Cat 2 or Cat 3 or Cat 4 suit to work on this panel. If you don't have one, Bubba ain't going to work on that panel. And sometimes that happens. So before your arc flash analysis is completed, get people using the tables, get them in FR clothing. Okay? So they're already used to it. This is what your labels might look like. This also has shock protection on it. It's got your shock hazard information, not just arc flash. This arc flash boundary here is 53 inches. What that means is if that particular panel is open, if it's open and we say you can see the shiny parts, then anyone within 53 inches of those exposed shiny parts has to be wearing Category 2 clothing. Has to be wearing Cat 2, which is 7 calories per square centimeter. That's what the energy is on this particular panel. Now, you see where our label says category appropriate? Sometimes people try to write everything required out there. It just won't fit. It clutters, it won't fit. That's why we pass out those posters for free. It tells people what Category 2 means. But I got a better idea than the posters. Do what we do. Train your people what Cat 2 means. Train them so they know. If you walk up to one of our field techs and say, hey, write me a list of everything required for me to wear in Cat 2, they can do it. They can do it. And ours are actually stricter than the tables in the book. Our safety guy tightened them up a little bit. So train everybody what Cat 2 means. It's a 480 volt panel, which means it's going to require a double aught glove class, which is a 500 volt glove. It shows you also the approach boundaries for electric shock. That's the 42-inch limited, 12-inch restricted, 1-inch prohibited. What that means is no one that's unqualified should be within 42 inches of a 480 volt wire or any conductor, unless they're escorted by a qualified person. But the restricted means, even if escorted, an unqualified person under no circumstances can get within 12 inches of a 480 volt conductor. Prohibited means 1 inch. Nobody, qualified or not, can get an uninsulated part of their body within 1 inch of a 480 volt conductor. Has anybody here ever reset a motor starter before? Opened up the panel, stuck your thumb in and reset the Allen Bradley motor starter? How close was your fingers to that 480 volt conductor at the bottom? Probably within 1 inch. It's common practice and has been for years for operators in factories to open up control panels and reset those buttons. I don't care if you've been doing it since 1952, they're not qualified to be in there. One time when I worked at Terre Haute, a Bemis company, I opened up a big 400 horsepower DC control cabinet, electronic big thing, had a lunch bucket in it because that panel was air conditioned because it was electronic, and so the guy stored his lunch in there. And he was just an operator. What he didn't know with these great big heat sinks right here in front of him had 600 volt DC on them. And if his bald head would have, somebody goosed him when he's in there putting in a lunch bucket, he could have been killed. So at first I thought it was tools, but it was tuna. I don't like tuna. So Proper use of the tables. The tables in 70E are important. And I don't mean to make light of them. They're not accurate. Okay? They're not your best choice. Guess whose company uses the tables exclusively? Mine. The guy that's been telling you they're inaccurate. And I'll tell you why we use them. Because we get hired to come put labels on. We never get to see labels, ever. Or if we do see them, we're hired to come fix a broken arc flash analysis that somebody did. So then we wouldn't trust the labels. And our people are in power plants and all kinds of stuff, factories of everything you can imagine every day, and we never get to see labels. Is anybody here a contractor? Work around contracting, your electrical contractor, HVAC contractor? You might be in somebody else's facility. Well, you can't say, I'm not going to work here unless you do an arc flash assessment right now. That's not going to happen. So what are you going to do? If you don't have labels, use the tables. Okay? So there is a use form. There's a good use form. But you can't just use the tables as a substitute for the full-blown arc flash hazard assessment. Okay? It can be used short-term, as a last resort. It's better than nothing. And the tables are called task-based. So not only does it ask you what kind of equipment, it asks you what you're doing in front of that equipment. Makes a difference if you're taking off a bolted door or if the door's got hinges. So you got to go through all these things. So recommendation is tomorrow, if you're not doing anything when it comes to FR clothing or any of these things, tomorrow start using the tables and immediately call someone to have an arc flash hazard assessment completed. Now, everyone needs to implement 70E. Don't do it for compliance. Do it to prevent injuries.